In this section, we're going to talk more about unit analysis and conversions. Well, this kind of explains the U.S. customary system, meaning feet, yards, that type of thing. Where did that come from? Well, it says that the modern length of 1 yard was defined by English King Henry I, who decreed it to be the distance from the tip of his nose to the tip of his thumb on his outstretched arm. That seems kind of long to me. But anyway, supposedly, according to this, that's where the yard came from. And yards and feet is what U.S. uses in inches. Most of the rest of the world uses the metric system, which is based on tens. Why we have to be different, nobody knows. The table in your text summarizes the official U.S. customary system, and I've included that on the conversion sheet that I posted in the previous section, showing standard units for length, weight, and volume. Example 1 says, the length of the Kentucky Derby horse race is 10 furlongs. How long is the race in miles? Well, furlongs is just another unit of length measurement, okay? And the fact is, you can look on your conversion sheet that 1 furlong, we're trying to change to miles, is equal to 0.125 miles. So, we're starting with 10 furlongs. And we're trying to get our answer in miles. Furlongs needs to go on the bottom, so it cancels. We discussed this a little bit more in the previous section. And 0.125 miles on the top, because that's what we'll be left with. So furlongs goes away, and we'll multiply 10 times 0.125 and get 1.25 miles. Example 2 says, this problem's funny, I think. You are planning to make pesto and need to buy basil. At the grocery store, you can buy small containers of basil priced at $2.99 for each 2/3 ounce container. At the farmer's market, you can buy basil in bunches for $12 per pound. Which is the better deal? Well, when we're comparing two things like this, we need to get them in the same units. So we're going to get in the same units of price per pound. We could go down to ounces if we wanted, but as long as we do both of them the same. But I'm going to get to the pounds. So that means we need to take $2.99 for 2/3 of an ounce and change that into dollars per pound. Well, if you look at your conversion sheet, or you might already know this, 1 pound is equal to 16 ounces. So ounces need to go on the top and 1 pound on the bottom. Before I give you the answer, let's talk about what you'll need to do with this. So you've got $2.99. You need to divide that by the fraction 2/3 and then multiply that by the 16 ounces. Okay? And it ends up with $71.76 per pound. So the small canister that you'll get at the grocery store is would be equivalent to $71.76 per pound. While you can get a bushel at the farmer's market for $12 per pound. So which is the better deal? Well, obviously, the farmer's market. Here's why I think this problem is funny, though. Because think about how much does basil weigh? How much basil would you need to make a pound? Are you ever in your entire life, maybe even, going to use a pound of basil? Oh my gosh, that's just wild. So yeah, I think that I'd rather just go to the store and buy the little 2/3 ounce container, but that's just me, unless I want it fresh, but I'm still not going to buy a pound of it. But like we said, the farmer's market is the better deal. The metric system, it's called the International Metric System, was invented in France late in the 18th century for two primary reasons: to replace many customary units with just a few basic units, and to simplify conversions through the use of a decimal or base 10 system. A base 10 system, I won't go into base 12 like Americans use because it's a long story, but base 10, why do you think that is what the people with the metric system decided to use, and what people before the metric system even tried to use? Why is 10 important? Why is 10 easy? Actually, it's because you have 10 fingers. That's really why. That's why we do it. It makes things easy because you have 10 fingers. There you go. So now you know. The basic units of length, mass, time, and volume in the metric system are meter for length, kilogram for mass, abbreviated kg, meter was M, second for time, which we abbreviate S, and liter for volume, abbreviated L. And everything else is just with prefixes, depending on if you're 10 or 100 or 1,000 or 1/10 or 1,000th or whatever. So here's common prefixes. Deci, abbreviated D, means 1/10. Centi means 100th. So like the fact that there's 100 centimeters in 1 meter. That's what that's saying. Milli means 1,000ths. There's 1,000 millimeters in 1 meter. And then we get even smaller there, but we don't really do that much in this class. Maybe down to micro, but... And then getting larger, deca means in the tens. Hecto means hundreds. Kilo means thousands. That one you see a lot. 1,000 kilometers. No, 1,000 meters are in 1 kilometer. And then you could go up to mega, giga, and tera if you're dealing with computers especially. So example 3 asks us to convert 2,759 centimeters to meters. So our conversion factor should be the fact that in 1 meter, there are 100 centimeters. And centimeters need to go on the bottom, which means we need to divide. 2,759 divided by 100, we'll be left with meters. And so that is 27.59 meters. The marathon running race, some marathon I guess, is about 26.2 miles. How far is it in kilometers? Okay, so we need to change 26.2 miles to kilometers. And there is a conversion for this in your book or on your conversion sheet. 1 mile is equal to 1.6093 kilometers. Miles needs to go on the bottom so that they cancel out. So 1.6093 kilometers is on the top, and we just need to multiply that by 26.2. We get 42.2 kilometers. Temperature. The Fahrenheit scale is what the United States uses. Again, we have to be weird. Celsius is used most everywhere else in the world. And the Fahrenheit scale is defined so that water freezes at 32 degrees and boils at 212. Celsius, freezing is at 0 degrees Celsius and boiling point is 100 degrees Celsius. That just seems to make so much more sense to me, but that's just me. And then Kelvin is a unit used in science. It has the same 0 point for freezing, or no, it doesn't. Its 0 is absolute 0, which means, and I think I'm right about this, it's the whatever item in the world that has the lowest temperature to freeze. Okay, that's what's defined at 0. The thing that's hardest to freeze in the world, basically. And we don't use the degree symbol with the Kelvin scale. So if you look at this, you can see how it relates. So Celsius is 100 degrees to boil, while Fahrenheit is 212. Kelvin is 373.15. Water freezes at 0 for Celsius, 32 degrees Fahrenheit. It's 273.15 for Kelvin. And then absolute 0 in Celsius is negative 273.15 or negative 459.67 degrees Fahrenheit. How do we convert? To convert from Celsius to Fahrenheit, multiply by 1/8 or 9/5 and add 32. So we have a nice little formula here. F equals 1.8C plus 32. And to convert back from Fahrenheit to Celsius, you can do F minus 32 divided by 1.8. To go from Celsius to Kelvin, add 273.15, or Kelvin to Celsius, subtract. We don't really have a conversion for Fahrenheit to Kelvin. We'll just go from Fahrenheit to Celsius and then to Kelvin. So the example says the average human body temperature is 98.6 degrees Fahrenheit. What is it in Celsius and Kelvin? So the formula for Celsius is F minus 32 over 1.8. So 98.6 degrees Fahrenheit minus 32 divided by 1.8 will leave us with 37 degrees Celsius. Convert that to kelvins. It is Celsius plus 273.15. So we've got our 37 from above plus 273.15. 310.25 kelvins. And again, we don't use the little degree symbol. Units of energy and power. Energy and power are two different things. You might think of them synonymously, but they're not. Energy is what makes matter move or heat up. And the international metric unit is the joule. Power is the rate at which energy is used. So energy is what makes the matter move or heat up, and power is the rate with which it's made to move or heat up, okay? And the international metric unit for power is the watt. 1 watt is equivalent to 1 joule per second. A kilowatt hour is also a unit of energy, which we see if you look at your electric bill. 1 kilowatt hour is equal to 3.6 million joules. A utility company charges 15 cents per kilowatt hour of electricity. How much does it cost to keep a 100-watt light bulb on for a week? Okay, so do you ever wonder when you left the light on in your bedroom as a child and your parents would yell at you, turn off the light when you weren't in there? How much was it costing them? Okay, so we want to change 100 watts into kilowatt hours. So we've got to change watts into kilowatts. And this was 100 watts in a week, so we need to change that to hours. Okay, so there are, in 1 kilowatt, there are 1,000 watts. And we're looking at per week. Let me pause this and take the bell off my kitty so y'all don't have to listen to it. He just came in from outside and he has to wear a bell to scare off the animals that he likes to bring in. Okay. So multiply by 1 week. And we need to change 1 week to hours. So we know that in 1 week, there are 7 days. And we'll get rid of this for a minute. In 1 day, there are 24 hours. Okay, so that is our pretty long conversion there. And in this, our watts are going to go away, weeks will go away, and days will go away. And we'll be left in kilowatt hours, which is what we're looking for. So you'll take 100 divided by 1,000 times 7 times 24 and get 16.8 kilowatt hours. Okay, so we've changed 100 watts into kilowatt hours because we needed to be in kilowatt hours because it said 15 cents per kilowatt hour, right? So, if 100 watts is 16.8 kilowatt hours, and we know that 1 kilowatt hour costs us 15 cents, then we can multiply and get that this light bulb cost $2.52 for a week. Well, that's like $10 a month. So, you know, if you turned off that light, then you could have saved your parents $10. The next part of this question asks, how much will you save in a year if you replace the bulb with an LED bulb? that provides the same amount of light for only 25 watts of power. Okay, so that's nice. Well, we know that 25 watts is a quarter of 100 watts, right? So this should cost per week 1/4 of $2.52. So this light bulb, the LED, would only cost 63 cents per week. That's a savings of $1.89 per week. That's pretty good. So how much is this LED bulb saving us for a year? Well, it's $1.89 for 1 week. And there's 52 weeks in a year. So multiply, that's a savings of $98.28 per year. So if you haven't already, go home, change out all your light bulbs to LEDs. Yeah, the LEDs cost a little bit more, but they're going to last you a whole lot longer and save you a lot in the long run. Density describes compactness or crowding. Material density is given in units of mass per unit volume, like grams per cubic centimeter. Population density is like people per square mile. Information density is in units of mass per unit volume, like gigabytes per square inch. Concentration is different. It describes the amount of one substance mixed with another. The concentration of an air pollutant is often measured by the number of molecules of the pollutant per million molecules of air, like parts per million. And blood alcohol content describes the concentration of alcohol in a person's body. It's the grams of alcohol per 100 milliliters of blood. Example 7, our last example says, a child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment with amoxicillin at a dosage based on 30 milligrams per kilogram of body weight per day, divided into doses every 12 hours, so twice a day. How much amoxicillin should the child be prescribed every 12 hours? This is very important stuff. Okay, if your doctors or nurses don't know how to do this, then they could prescribe your child with the wrong thing. And if you know how to check it, then you can make sure they're not prescribed with the wrong thing. Okay, so it's 30 milligrams per day. So we need to divide that by 2 to make it 12 hours. So 15 milligrams every 12 hours. And it says that the child should have 15 milligrams for every 1 kilogram of body weight. Let's write this differently. So the child weighs 15 kilograms. So 1 kilogram of body weight will get them 15 milligrams of amoxicillin. Multiply, they need 225 milligrams of amoxicillin every 12 hours. The second part of the problem says, if the medicine is to be taken in a liquid suspension with concentration 25 milligrams per milliliter, How much should the child take every 12 hours of that liquid? Well, we're starting with 225 milligrams. And our suspension is 25 milligrams to 1 milliliter. So divide 225 by 25, and we'll get 9 milliliters every 12 hours. Okay, so this section was fairly long, but it has ended. And go work on your assignment and let me know. Be sure and email me if you have any questions about any of the problems.